Today I will be talking about creating contracts on the Ethereum blockchain. So we try to make our own private token. Not sure if we'll make it, but no worries. I have working demo with me, so we'll first try, and if it will fail, because it's live coding, so we probably do, and we can run the working demo. So, have anyone heard about blockchain and knows how it works?
There's a lot of money there.
Except that. So yeah, so the blockchain, the name comes from because on the blockchain you have blocks with the data, and each block is calculated. For example, on the Bitcoin blockchain is calculated every 10 minutes. So in the block you have all the transactions that people want to do, like send from one account to another account. And every 10 minutes, one block is added to the blockchain, and it cannot be changed. So so if you write something to the blockchain, it cannot be changed. So it stays forever, and it's public. So writing contracts requires a lot of tests and code reviews, because it's about money, and you can change it when you publish it. So. Today we'll do it YOLO style, so no test, no nothing, because it will take too long. One more thing, on Bitcoin blockchain you don't have smart contracts. Smart contracts were introduced by Ethereum, so that means that you can run some code on the blockchain. So it's like you are invoking some code on the others people computer. The people that are running nodes in the network, they are computing your code. So you're writing your code and you have to pay them for computing your contract. So for each transaction on the blockchain, you have to pay. So let's write our Aurity coin that can be, for example, used internally to earn some kind of bonuses. Like, for example, you can earn some Aurity coin and then spend it for, I don't know, conference tickets, pizza, or I don't know. You can make up something, and yeah, that will be run on the Ethereum network. So let's start coding our contract. So the contract is the code that will be run on the Ethereum network, and this contract we start with keyword. It's one more thing. It's a online IDE for writing contracts for Ethereum. It compiles the code, and yeah, you can run it on the test network. So here on the first line, we define which version of the Ethereum we want to use. So it's 4.17, and here we define that it will be a contract. It's the language is some kind of Java-like for me. So the first thing, we want to be compliant with the ERC20 standard. It's the standard for Ethereum tokens, and we define the name of our token. It will be string name. It will be public, so everyone on the network can see it, and we'll name it Aurity. There you go. And something wrong. Semicolon. Got. Yeah, I think it's like that, because functions are the other way, and like that. Oh, you need this. Yeah. Okay, so we have a name. Then we need a symbol that will be used on the Ethereum network. Symbol, it will be with capital letters, like that. Then we have to define how many decimals our token will have. So we'll simplify it. So we'll go with 0. It will be unsigned integer. Unsigned means only positive values are allowed. Public decimals, it will be 0. Then we'll define total supply of our coins. Unsigned integer 8 means that it's written on the 8 bits, so maximum value is 256, so we need something bigger. Let's take 16, make it public. Total supply, and we'll make it 1,000 tokens will be ever available. We'll skip this one for now. Contract owner. Okay, we'll go with the constructor. So we need to define a constructor. So constructor is the code that will be invoked when the contract is deployed to the network. So there will be function, Aurity function, Aurity.co, and we make it public. All right, what can we have here? So what we want to do, we want to store the address of the creator of the contract. It will be useful later, so we'll make a variable to keep it. There is a special variable called address for keeping the addresses on the Ethereum network. It's the address of the wallet of the owner. So make address owner, and it will be public owner, like that. And it will be empty, and it will be instantiated inside constructor. So the owner will be, there is a special object which is called message, and inside message we can find an address of the developer who published this contract. So it will be sender. Okay, so we store the address of the owner. What else do we need? Okay, we define balance of each user of who will possess Aurity.co. So we'll use something which is called mappings, and mappings you can compare to hash map in other languages, and we want to map address to unsigned 16. So we define that address can have some value of tokens, some number of tokens, and we'll call it balances. I forgot about public again. No, it's mapping public, like that. Or I forgot about something. Maybe it's after. I don't remember. Whoops. Yeah, it's after. Yeah, it's this part is weird sometimes, where to put the accessibility. Okay, so we'll define that the creator of the contract will have the total supply, so he will possess all the tokens. So balances owner. Let's give him total supply. So he has now all the tokens on this contract. So he has 1,000 tokens, and he can distribute it later. All right, what else do we need? We can write a function that will return the balance of each user. Function. Now it's the name, so balance of. We have to pass the address of the user. The function is public. It returns only the balance. It doesn't change the state of the contract. So we can call it view. So it says that it only returns a value. And we can say that it returns unsigned integer 16. Okay, now we want to return balances and pass an address of the account. All right, so we have this one. Okay, we want also a function to send from one user to another user. We want to send our Aurity tokens, so we need that transfer function. So let's write it. Function transfer, and we want to define from where to whom. So we need address from and address to. We'll write with this one and this one, make it public, like that. All right, so what you want also to do here is make sure that this function can be invoked only by the owner of the contract. No one else can invoke it, because each function that you see here is available to the public on the blockchain network. So anyone who knows the address of this contract can invoke it. So we need to make sure that it can be only invoked by the owner. So we can write a special function which is called Modifier. And Modifier is some kind of, I don't know if you know the pipelines from other languages, something like that, that it will be invoked before the function, the body of the function starts. Is owner, and we want to check here, we want to require that the owner is equal to message sender. So it's that we want to check here that the owner of the contract is equal to the person that is invoking this function. So message sender, it's sending the function. And the special, okay, so doubled here. And the special character that we want to place here is this. What it means exactly. 1 second. So we can use this function here as a pipeline. So it will be invoked just before the transfer function, just before the body. So what this means, if we have something like, if we put it here, it takes this part and just places it here. So it's the same meaning, right? So it takes the body and put it there. Okay, what else do we want? So we can now transfer one coin, coins from one account to another. So balances of the wait a second. So transfer, okay, so balances from account. Maybe we want one second, I need the cheat sheet. Not here, here. Yeah. The owner. Okay, so we want to this function to be invoked only by the owner. So we need only address 2, and we want a value that amount of tokens that we want to send. So we want to remove the value of the tokens that we sent from the contract, from the owner amount. So we need to decrease the balance of the owner by the value. So balances owner minus value, and we want to add this value to another person balance. So balances 2 balances 2 plus value. Okay, and we also want to make sure that the owner have enough coins to make this transfer. So we can put it and we require that balance of the owner is greater or equal to the value that we want to send. I'm always forgetting the semicolons. Okay, another thing that we want to add is event. Event is something that is broadcasted when something happens, when the event is invoked. We broadcast to the whole Ethereum network, and anybody can listen to it. And it's useful, for example, for pages like Ethereum Scanner. I don't have it. Ethereum Explorer, something like that. For services that listen to the network and register all the events there. So we can see that the transaction from one account to another account actually happens on the blockchain, and we can trace it. So we need an event for that will be triggered. Event transfer with a capital letter. And here we want to register from where to whom we are sending. So address, and there's one special keyword that we need to use for those services. You can find it in the ERC20 specification. From, and where do we want to send it? Index at 2, and this one was probably value, if I remember correctly. Event transfer, yeah, it's value. All right, we have event, and after we send the value coins from one account to another, we want to invoke an event that we want the Ethereum network to know about this. Transfer, we sending from owner account to account with the value. All right. What else we need? Okay, so this service, we need user to register. To register before they can buy something or before they get some tokens, because administrator will send them tokens which they can spend later. So we want only specific user to use our contract. We don't want everyone to use our contracts, right? So we can add another mapping with employees or with accounts that will be allowed to use the methods from this contract. So another mapping, let's call it employees, and we'll use the Boolean public employees. Okay, so we'll use address and call it employees. Yeah, we want to match each address with Boolean value. So here we write function to approve our employee, but only by admin. Function approve employee, and we want an address of the account that want to be approved. Address public, and this one can be also invoked only by the owner of the contract, so only by the administrator. Okay, and when we approve the account, we'll add it to our mapping. So employees, address of the employee, let's change it to address, would be easier. Address of the employee, and we want to change it to true. So now he can access. We'll have a possibility to access the pay function, which we'll define in a second. Okay, so if user is registered and approved by administrator, he can now buy something with his Aurity coins. So let's write a function to spend Aurity coins. So that will be pay, and we want to define a value that we want to spend. We want to make the function public. What we need now? We need now to our user have to have the amount that he wants to spend on his account. So require balances of the message sender, so the account that is invoking this function. Balances message sender to be greater or equal to the value that he wants to spend. And now we do something like that, but the other way. So we add the coins, we return coins to the admin account. And we take this value from the invoker account, so message sender. Message sender minus value, and we want to invoke the event to the Ethereum blockchain. Again, owner. No, now it's from, so it's from message sender to owner, and the value that we want to spend. So probably that's it for our contract. We can now test it on the test network. Some warnings, but we probably shouldn't care about it too much. So you have so few options to run this contract. There is JavaScript virtual machine. So if we use virtual machine and deploy this contract, each event or each function that changes the state on the blockchain will be invoked immediately. But if we use, for example, injected Web3 provider, Web3 is a provider that interacts with Ethereum. In the Ethereum blockchain, it's JavaScript provider. Then we'll have to wait for this function to be processed. So every change on blockchain takes some time to be so it has to be processed by the nodes and approved that it's correct. So for now we'll use JavaScript virtual machine to make it faster. We have few accounts to deploy the contract, so we'll just press create, and we can see all the functions that are available on this contract. As you can see, all these don't have to be defined, like the getters. They are defined by default. So if we click name, we get back the string of the name of the coin, it's Aurity, etc., etc. So yeah, actually we can do some testing here to see if it's working properly. So let's take the address of this account and put it into balances to see if actually the owner of this contract have 1,000 coins. Let's click on balances. Yeah, the owner of this contract have 1,000 coins. What else we can check? Nothing else. Okay, so let's approve one of the employees. So we change now the account. We're selecting another account that will be one of the employees that will register with his own account. We copy and we approve that this employee can use our contract. So yeah, it's approved now. And now we switch back to the admin account, because only admin account can send some coins to other accounts. So from admin account to this is address of the employee account, we are going to send 20 Aurity coins. Okay, they transferred, and now let's check if the employee account got some coins. So balance of the employee account, it's this one, should be 20. Yeah, it's 20. We have transferred successfully 20 coins. All right. So this is the JavaScript network, and note that nothing else can be changed here. We have now it's somewhere here. Not sure if I can find it here, but we'll see it on the Ethereum network. So if we want to change something in this code now, this contract will stay forever. If we change something else, we have to deploy it again, and there will be another contract. So if we have a bug here, we are probably screwed. So yeah, we can also add some functions to deactivate contract, but it's more advanced stuff. Okay, so now let's change to the Ethereum test network. There is a plugin that can be used with Chrome, and it's a kind of wallet to keep the Ethereum, and with it you can interact with Ethereum network. It's some kind of bank account. You have your address, you have amount of your tokens, and it's used to interact with the Ethereum applications. And you have some accounts. I have some accounts prepared. So the account 1 will be the admin account, and account 5 will be the employee account. Employee account have 2 Ethereum, and the admin account have 16 Ethereum. So admin account will deploy the contract. Okay, it's saying creating of Aurity.co pending, because now we are on the test network, so the nodes have to, it's called mining, have to mine and approve and add it to the blockchain. So we have to wait some time for that. It's about 15 to sometimes to 1 minute, depends on the algorithm that calculates the time.
Do we have to pay for this first?
Yeah, exactly. There sometimes it pop-ups, but today it doesn't. So yeah, exactly. There is a transaction. MetaMask informs you that your account wants to invoke some transaction, and here you have details how much you have to pay for this contract to be deployed. As you can see, you have to pay 0.005415 Ethereum, which is equal to $3.72 USD. So you can reject it or submit. If we submit, then the transaction will be sent to the blockchain, and it will be.
But it's not test network.
It's test network. It's test, and I have some fake Ethereum, so you can go to the page. I think it's Faucet, something like that. Ethereum. Yeah, which one is it? Faucet. Yeah, I think it's this one. Yeah, something like that. You just no, not this one. At Ethereum test network. Anyway, I will find it later. But you have just to tweet on Twitter, and you have to paste the link of your tweet into that faucet, and it will send you some fake Ethereum to your account that you can use. The user can spend on the test network. So yeah, it's deployed. Now we can see the transaction on the Ethereum blockchain. You can see, what can you see here? The contract. Now we have the contract address. Now it's like address of the wallet, but here you can find our contract. You have the creator of the contract, how many transactions, etc. Some details. Here you have the actual value, how much it costs. What else? Yeah, and this is the code that was sent to the blockchain. If we transfer it to ETK, nothing here. Okay. All right, where was it? Okay, so we're using now our MetaMask account, and what can I show you here? Okay, we can add the. Here we have tokens. Some if you using some customized tokens, or if you participate in ICO. ICO is like you sending some Ethereum and you getting back. So like you want to buy some tokens that are not available on the market yet. You participate in ICO, so it's like IPO in the real life. Like you want to invest in some company. So you need a token. You need a contract address, and we have to take it from here. Here is our token address. Where is it? It's here. And here's MetaMask, and we can add our token. Okay, you see it found its Aurity, and they have 0 decimals of precision. We can add it, and it should show that our account have 1,000 Aurity coins. All right. Let's send from one account to another account, and let's see if it works. Now we want to transfer to account 5, so we need an address of account 5. This is the address of account 5. We have to switch back to account 1 because we want to send from account 1, which is admin account. We want to transfer to this account, and let's send him 20. And again, this is transaction that changes something on the blockchain, so we have to pay for it. Now we have to pay for it 18 cents to transfer accounts from. Yeah, it's a commission for the miners for calculating your transaction, for approving your transaction on the blockchain. So we press submit, and now we have to wait again. You can see the transaction, and it's being processed, not yet. Not yet. Not yet. Not yet. Not still not yet. Now it is. It's being processed. You see, it was included into block number. You can see the block number, which will be added to the blockchain. Let's refresh. Yeah, it succeeds. So probably account 5 should have 20 tokens. Let's check that. Now we have 980, and the account 5 will have. The MetaMask doesn't work yet very well, so you have to do like that. Yeah, we have 20 tokens. So we sent 20 tokens from one account to another account. All right, so that was the writing Ethereum part. Do you have any questions about this one?
Yeah, there's some fake token.
Sorry?
Fake ads.
Fake currency, you mean?
Yeah.
Yeah, it's fake because it works on the TS network, but you can buy some Ethereum on the exchange, and
Same price.
Probably the same price. You can buy some tokens now on the exchange, buy some Ethereum, add to your account, and run it on the real network, and it will work like that. But you will have to spend real money. Yeah, that's the difference. Yeah. Any other questions about this part?
Can I get 10 tokens?
Yeah, you can get 10 tokens, but do you have address?
Oh, cool. So also like, so because we have those pay functions, right, basic stuff, and then when I want to deploy this to real network, do they kind of validate the transfer methods and if it works?
No, nothing is validated. It's on you. So if you make an error, it's your problem.
But so then, for example, when I actually kind of do ICO, for example, right?
Yeah.
And then we'll say, hey, actually, you can buy our tokens.
Yeah.
And then you kind of pay us, but then we might not pay them actually.
Yeah, so you'll be a scammer.
Okay.
That happens a lot in the blockchain community, that they say that, yeah, they promote a token, say it will be do that. There's a lot of hype, people send Ethereum and they disappear with all the money, and you can't reverse the transaction, so yeah.
But it's like two cases, right? Like you can actually get money, like you can get the token, but then it's not worth anything more, let's say, or you don't get any token.
You can make a contract that won't send the token, but you can make a contract that will actually send the token, and how much it will cost, that depends on the how you say it, on the demand and the supply. So if you have to write some functions so it will be available on the exchange, etc. So you apply to exchange. That you say that, yeah, I have a token, I have project for that token, they validate it and they put it on the exchange, and then you have demand and supply, and that's it. If there is high demand, the price grows. That's how it works. You don't define the value. You can define how much you want for on ICO, how much you want Ethereum for, how many tokens. That's the only thing that you can.
Are there like any certificates that actually, my pay function works well, or like transfer function is like works as expected?
You mean something like audits? Or yeah, there are some companies that do audits. There is library, we just call it ZeppelinSolidity. ZeppelinSolidity is the most popular one, I think, for the Ethereum, and you have some useful code for Ethereum, like ready contracts or contracts that's for ICOs, because if you write it, they're mostly the same, right? The only thing that you want different from this is your business logic. And what can you see? They use it there because we are using here like simple math, like adding and subtracting. You want to use something like a safe math, or there's a lot of gotchas in the Ethereum. So
it's because like decimal places as well.
Sorry.
Decimal places as well.
Yeah, decimal places as well, because you have to calculate from it's called, for example, GUI. You have a lot of jednostki. Yeah, a lot of units on the Ethereum. They're like a lot of this. I think the default one is 18 decimal places. So you have to transfer from you have to do calculations if you want to send 0.005, etc. You want to use some ready code that was audited and it's open source and it's checked. So if you go to the contracts, I think, token, yeah, you have here ERC20, and if you take a look, it's a basic token. And you can just extend, because Ethereum give you possibility to multiple inheritance, so you just say is, and the name of another contract. And you can see you have total supply, you have the method that we wrote, the transfer method, you have the transfer function, balance of, it's just it's compliant with the ERC20 standard. So yeah, there are a lot of contracts, and you can choose which one you need for your purposes.
Okay.
Any other questions about this one?
So you want to use this? We can actually have our own coin and actually have some like additional, like some money for, let's say, like those conferences and that kind of stuff. Because at the end of the day, we can agree that okay, we'll buy this coin from you.
Yeah, that's what this service will be about. Like now, I will register with my account, with MetaMask account. You will be an admin, so you'll have the admin view. You can approve that, yeah, I am actually an employee, not some external people. And I will, after approval, I will have a view with my balance and things that I can buy. So conference tickets, I don't know, maybe a pizza that you can order if I'm at home, something like that. You can make up some things. So that will be the front end part.
If there's no validation, it's basically about trust. Right?
Yeah, so yeah, it's trust.
All right, man.
Yeah, you have to trust that the people that wrote the contract, because what you can see on the blockchain is only bytecode. You can see the code like that unless they open source it. But most of the tokens, I think, are open source, so you can actually check what's in the contract.
So you can actually fork someone else and say, okay, change this to Aurity.
Yeah, that happens. Like people just fork the successful project, change the name, change the supply, and actually that's it. And they release it as their own coin, and they're getting money from that. Because most of the people doesn't know programming and they don't check what's in the code. And yeah, they're doing some hype about it, and that's it. And you have a coin, just put it on the exchange.
So then if you want to write tests, do you have like some tools for that?
Not in the Ethereum, but you can now compile it to the JSON and use the Web3. And with Web3, you can use normal JavaScript to test it. So yeah, normal node assert functions.
Then we'll use Łukasz.
Haven't tested with Jest. Maybe it works, but I don't know if it's useful in the. Let's snapshot the contract.
Can you have like some more like smart contracts? For example, I don't know, like invoke this like automatically on some events.
Some like other contracts listening to this contract.
Yeah, like I don't know, maybe saying okay, if tomorrow.
Yeah. So on the blockchain, you don't have outside information like about the time, about the result of the game, about the current rate of the Polish zloty to the sterling to the pound. So you want to use something like called oracles. And with these oracles, you can ask external service to provide you that data into blockchain. So there are audited services that actually provide this information. I don't remember now the names because I haven't used the oracles, but I know that something like that exists, and you can do that. You can get that data from the outside world. So yeah, you can do something like invoke this function on this date.
Right. Exciting, we have our own coin.
Okay, so front-end part.